Everybody, I hope you all are doing great. So you must be wondering why I'm smiling, right? You look to this side of the screen, I think time must be visible to you, right? It is hard to stay consistent, right? And if you are staying consistent in something, right, that's the like massive respects for you all, right? So here, everybody in my home is actually sleeping and I'm here recording. I have to speak very slowly, so कोई बात नहीं. Let us start with this question itself. So the question is saying, given m cross n grid filled with non-negative numbers, okay, find a path from top left to bottom right which minimizes the sum of all numbers along its path. So you have to find such a path whose sum is minimum if you're starting from the top left and you want to reach the top right. And here a note is given, you can only move either down or right at any point of time. So down or right. Let us quickly analyze this question and try to solve it question using dynamic program. So as you can see, like this is the test case they have given us. So this is the grid and they're telling that if you want to go from top left to bottom right, 7 is the minimum you can make. Let us analyze this test case, right? So they are telling us that in a single point of time, I can either go to the right or I can either go to the round. If you look at this question closely, they are saying here. So either you can go down or right. Okay. So what actually are we supposed to do? Right. So what are the possible paths? I can go to this cell from this cell to this cell using this path. What is the sum of this path? It is 2, 7 and then 9 and then 10. So 10 is the sum of this path. If I take this kind of path, I'm at every point I'm going down or right. I'm not making any path like this. We are not supposed to go left, or I'm not taking any path like this. I'm not supposed to go up at any point of time. I can either go down or I go right. So right, right, say right, down, right, down. So what is the sum of this path? It is 8, 9, 10, 11 is the sum of this path. If I go down, down, right, right, then the sum is 6, 7, 8, 9 is the sum of this path. But if I take this kind of path, right, right, down, down, this path is resulting in minimum sum starting from 0, 0 all the way 0, 0, 0, 1, 2, 0, 1, 2. We are starting from 0, 0 and we want to reach the cell n minus 1, n minus 1 with the minimum path itself. So this is the problem statement. Let us try to derive some recursive relationship in this problem. So if we want to derive a recursive relationship in this problem, you can see I'm starting from 0, 0 and I want to reach the bottommost path, right? So you can say I'll be starting from 0, 0 and from 0, 0 I can either go right or I can go down, right? If I go right, whenever we go, like this is a general thing that this is if you're standing on I comma j, when you go to the right side, that is I comma j plus 1. When you go to down, it is I plus 1 comma j. When you go to the left, I j minus 1, and you go to the up, I minus 1 j, right? So but like in this particular case, I don't need left and up positions. I can only go right or down. So whenever I go right, I'll be doing I comma j plus 1. I will be as it is. This is the I parameter. This is the j parameter. I will be as it is. J will be incremented. So I'll be standing on 1. So if I go right, I'll be standing here, right? From this position, now you can see there are more two possibilities. I can either go right or I can go down. If I go right from this position, if I go down position, if I go right from this position, you can say 0, 2 is the point I'll reach. If I go down from this position, definitely the cell I'll reach is I plus 1 comma j. So 1 comma 1 j will be as it is. From here to be 1 comma 0, right? Now from this position, if I go right or down are the two, or you can say, options I'm having. If I'm going right from this position, you can definitely say that I'll be going 0 comma 3. If I go down from, let me use a different color, 0 comma 3. If I go down from this position, I'll be standing on 1 comma 2, right? This I will be incremented, right? Now 0 comma 3, yeah, is this any valid index? No, this is not a valid index. This is actually out of bounds. This particular array is not having 0 comma 3 index. So from here, I'll simply return that infinite is the cost to reach the bottom right cell, to go from this particular cell, from this cell to reach the bottom right cell. It is infinite cost, right? Now from this cell, you can see that I can either go right or I can either go down. If I go right, if I go down, if I go right from this particular cell, you can definitely say that j will be incremented 1 comma 3 I'll reach. If I go down, the cell is 1 comma 2, 1 comma 2. I cannot go right from this cell, right? Because there is no cell there. I'll be only be able to go down. So if I go down from here, I'll be standing on 2 comma 2. Now from this 1 comma 3, you can say definitely this is an invalid index. I'll return infinite from here. This cell although is a valid cell, and from 2 comma 2, we simply return this data that I have reached the cell. So I cannot, like, I don't want to move from bottom right cell, right? I'm already standing on n minus 1 comma n minus 1. I'll simply return what? The data which is present on this particular index. I'll simply return 1 from here, right? So 1 is returned. Now this 1 comma 2 is having two options, either go right or down. What is the minimum of these? 1 is definitely the minimum one, and 1 comma 2, what is the data on 1 comma 2? 1. So I'll be returning 1 plus 1, which is 2. So I'll be returning 1 plus 1, which is 2. So I'll be returning 2 is the minimum I can do if I want to go, if you want to go from my particular cell to the bottom right cell. 2 is the minimum cost I can make. Now you can see this has to decide now, either it can go right or it can go down. Definitely going down is giving me the smaller result. Definitely you can see from here I don't want to go right, I'll only be able to go down. So I'll select this down. What is the data on this particular 0 comma 2? 1. So the result I'll return is this 2 plus the data on me, which is 1. So this is what I'll be returning to my you can say child itself. So 0 comma 1. Now 0 comma 1 से क्या होगा? We are standing on 0 comma 1. Now 0 comma 1 we will have to decide either right or down. It has not decided yet for down. So let's make two calls for down. So if I go down, like from here I can go right, I can go down. If I go right from here, can we simply see that I'll simply again reach 1 comma 2. I've simply again reached 1 comma 2. And here can I simply say that memoization will take place, right? Memoization can take place. Can I directly derive memoization now? Yes, definitely I can, right? Because recursion is what? We are exploring everything. In memoization, I'm limiting my calls for the calls I've already calculated answer for. I will not be calculating again. 1 comma 2, I'll always return 2. From here also, can I say I'll simply return 2. This is the memoization itself, right? This is what we have been learning from the past videos. 1 comma 1 say if I go down, if I go down from 1 comma 1, if I go down from, I'll be reaching 2 comma 1. So 2 comma 1 is the cell I'll reach. From 2 comma 1, I can either go right or I can go down. If I go right, if I go down. From 2 comma 1, I go right side. I'll reach 2 comma 2. Yeah, is this the destination? Is definitely this is the destination. From here I'll simply return whatever data is there. This is also base case. If I reach n minus 1 comma n minus 1, I'll simply return 1. If I go down from here, yeah, from this cell, if I try to go down, there is like no possible way to reach this cell, right? So I'll be out of bounds. So definitely if I try to go from down from here, so 3 comma 2 I'll reach. Definitely this cell will be 3 comma 2, and this is an invalid position. I'll simply return infinite from here. Now since I've returned infinite from here, you can see this will be choosing the minimum of both these, and 2 comma 1 will be choosing this as the minimum one. So 1 plus the data on 2 comma 1 is 3. So I'll be returning 3 from 2 comma 1. Now 1 comma 1 has to decide either go with this 2 or go with this 3. What will 1 comma 1 choose? It will simply choose what? It will simply choose the minimum one. It will choose 2 and 5 will be added to that. 1 comma 1 will be returning 7, which is of course 5, which is data on 1 comma 1 plus the choice, the minimum of both these options. So 7 is returned from here. As soon as we return 7, 0 comma 1 has this choice. 0 comma 1 has this choice to either go right or to go down. Now definitely if I go right, I'll be getting 1 only. If I go down, I'm getting 7. Here, what is the scenario? What is happening here? Right, definitely I think I've made a mistake here, right? I have selected 2 as the minimum, and from this position I'll have to, yeah, 0 comma 2, I'll select 2 as the minimum, definitely, and okay, I'll be returning 3. Yeah, I'll be returning 3 from this. Sorry, if you were able to detect this mistake, then good, yeah, you're understanding the recursion calls, okay? And sorry, it actually becomes very tedious, like for you as viewers. If I make mistakes, I'm completely sorry for that. So 3 comma 7, okay, so 3 comma 7, 3 is the minimum. Of course you can see from, if I go here I'll be reaching in 3, if I go down I'll be reaching in 7. Definitely 3 is better. So 3 plus the data on 0 comma 1, 3 plus 3 is 6. I'll be returning 6 itself, correct? 3 plus 3 is 6. I hope I'm not making any mistakes right now here. Okay, so all right, so 6 is the thing I've got from the right side. If I go down from here, you can say I'll be reaching 1 comma 0, and from here I can go 2 calls right or down, right? If I go right from this particular index, I'll be reaching what index? I'll be reaching, if I go right from this index, I'll be reaching 2 comma, can I say 1 comma 1? Definitely when I go right, j plus 1, so j plus 1 is 1, and 1 comma 1 I've already calculated the answer for this. I always return 7, so I'll simply return 7 from here. Now if I go down from this particular index, I'll be reaching 2 comma 0. Now from 2 comma 0, I've not calculated the answer for this before. So for 2 comma 0, what will happen? I'll take two calls, right or down. Definitely, you can see if I go right, I'll be reaching 2 comma 1. From 2 comma 2 comma 0, if I go right, I'll go 2 comma 1, 2 comma 1. Now if I'm standing on 2 comma 1, can I simply say this? That since I'm standing on 2 comma 1, what will happen? I'll be returning whatever result we have calculated. Like 3 it always returns, I'll return 3 from here. And if I go down from this index, can I simply say, if I'm going down from this index, I'll reach what? Here I'll reach 3 comma 0, and 3 comma 0 is invalid index. I'll simply return infinite from here. Now it is up to 2 comma 0 to choose 3 or infinite. It will definitely choose 3. And if I am choosing 3, 2 comma 0, 3 plus 4, right? 3 plus 4 is what? It is 7. I'll be returning 7 as well. So 1 comma 0 is having both the same choices, right? So I'll simply return any of them. I'll choose any of them, and 1 comma 0, 1. So I'll be returning 8. 7 plus the data on 1 comma 0. I'll returning that. Now I comma j is having a choice either to go along with 6 or to go along with 8. If I go right, this is the best I can do. If I go down, I think this is the best I can do, right? So what according to you all is the best choice? Right? What according to you all is the best choice? Definitely, you can simply see here. I think this is the best. Yes. So you can simply see that I'll be choosing the minimum one, and when I choose the minimum one, I'll add data to it. I'll simply return 7 from here. And this is the recursive code itself. Let us write the recursive pseudocode itself. At every point, I'm having two choices, either go right or down. In the return, I'll choose the minimum of right or down plus my data. That will be simply the recursion call itself. Let's write the pseudocode quickly. Let's quickly write the recursive pseudocode. So function, I'll be passing the grid here. I'll be passing I and j. These are the two indexes I'm standing on, right? This question will actually make us learn something. Dhyan se dekhna. So what is the edge cases? So if I'm out of bounds, I'll return infinite. If dp of I comma j, right? This is actually memoization code I'm writing now. So let us write recursion only. So this is out of bounds condition. Now integer, if I go right from this I comma j, right, if I go right, I'll be calling the function arr I comma j plus 1. Integer, if I go down, the call will be simply function call and arr of I plus 1 comma j, right? And what do I have to return? I have to return math dot min of, I'll select the minimum of both these plus the data on me, right, comma down plus error of I comma j, right? So this all we have covered. This is the recursive pseudocode. Now you might be wondering why do I always draw recursion? Why do I always write this memoization code? Here actually, I don't care if the video will be a little bit longer. There are students who need these kinds of help. Like, of course, everybody is not having a perfect recursion. If you are thinking that it is a waste of time, yeah, actually there are students who actually want this kind of help, right? So, and this is the approach only we are discussing. So definitely I would definitely do the recursion calls and the pseudocode for every question upcoming. I don't care if the videos are becoming longer. You can of course skip the part you've already understood, and I know I repeat a lot of stuff all the time, so that you all get minimum doubts, because this is not a live class, right? This is a video. So in a video I want to ensure that everybody has minimum doubts, right? So let us move forward to the code itself. So here we are on the editor itself. Now I'll simply write here. So let's start writing the recursive code itself. Integer array grid will be passed here, and I comma j will be passed here, correct? Now if I becomes less than 0 or j becomes less than 0, right? These are all the out of bounds condition. If I'm going out of bounds just for 2D array, I becomes less than 0, j becomes less than 0, or I is equal to grid dot length, or j is equal to grid of 0 dot length, right? These are all the conditions which are out of bounds condition. Let me make a little bit smaller. Okay, yeah. So these are all the out of bounds condition. If any of these conditions hit, I'll simply return maximum value, integer dot max value, right? Else what option I'm having? I'll try to get the right recur for grid I comma j plus 1. I'll try to get the down recur for grid of I plus 1 comma j. I'll return math.max of math.min, sorry, I have to get the minimum path sum, math.min of right comma down, and you already know that if we want maximum, so इसका maximum कर देना, plus grid of I comma j. The data on me plus whatever choice is minimum, that's what I want to return. I'll simply return here, return recur, I'll call recur function, and grid I'll pass here as it is. 0 comma 0 is the place I'm starting from. So let's call this function and let's see if this initial test case pass. Of course, this is not the ideal approach, right? Okay. Integer math dot max value. Okay. We are returning math dot max from here. All right. All right. There is one case. If I is equal to grid of grid dot length minus 1, correct? And j is also equal to grid of 0 dot length minus 1. I'll simply return whatever data is there, right? Grid of I comma j, right? This is the case for this condition when we are already standing on the bottom rightmost cell. So this case we have to handle. I'll simply return this thing, and now this code will simply function, right? Debugging is also a very important part of DSA, you can say, learner, right? So this is the recursive code. Let us quickly convert this into memoization itself, and yeah, then move to tabulation. Now for memoization, we need a DP array, right? But how many dimensions will be that in will be there in a DP array? I told you that the number of parameters which change in recursion are the number of parameters you should have in your DP array. How many parameters are changing here? J is also changing and I also changing. So you can say 2 parameters changing. So our DP array will look like how? DP is equal to new integer grid dot length comma grid of 0 dot length length and grid of 0 dot length. Correct? Is this clear to everybody that the DP array will be of 2 dimension because we are changing 2 parameters here? Of course, we want to remember the answer for, right? You can see we were remembering the answer for 2 comma 0. We were remembering the answer for 1 comma 2. I will need a 2D array to store 1, 2, right? This kind of data. So this 2D array, grid 2D array I'll take, which is a DP type. I'll create a function called memo, right? Public integer memo. I'll pass the grid here. I'll pass integer I, integer j. I'll pass the DP here, integer 2D array DP, right? These are all the data I'm going to pass as parameter. Now to write the memoization code, I'll simply copy paste the recursion code. This is the trick I told you all, right? I'll simply copy paste the recursion code, and wherever I'm calling recursion function, I'll name it as memo. This is the function name, and also I'll add DP array in the recursion calls itself. Now, the only thing which is remaining right now, if I have already got the answer, if DP of I comma j, right, you can see they are having 0 as well, right? So I have to initialize the DP with minus 1s, so that you know, that is, if DP of I comma j is not equal to minus 1, I will return what? DP of I comma j. If it is equal to minus 1, this means that we have not calculated the answer for DP of I comma j. And then I'll calculate the answer, and before returning I'll do what? DP of I comma j is equal to math.min of this, right? I'm remembering my answer here, and here I'm recalling the answer. Is this clear? The only thing which is remaining is I have to call the function and I have to initialize DP with all minus ones. How can we do that? I'll simply traverse in this array dp.length I plus plus. I'll simply write arrays.fill DP of I with minus 1. Every ith array I'll fill with minus 1. So every array inside this 2D array, every position will be having minus 1 initially, stating that we have not visited this I comma j cell at all. Okay. Now let us quickly call DP of let's quickly call this function memo. I'll pass the grid here. I'll pass 0 comma 0 as it is, and I'll pass the DP array, right? Let us now try to submit this problem itself, and let's see if it passes all the test cases, right? Because it is also space optimized. The time complexity for this code is n cross m, right? Definitely it is space time optimized also. It is not space optimized, sorry, it's time optimized. So 99% it is beating. Definitely it is a very good solution. Let us now quickly convert this memoization solution to tabulation solution itself using our trick which we have been following through all these videos. And if you are following all these videos through, I'm pretty sure that you will get whatever tricks I'm using to convert recursion to memoization to tabulation, right? it might seem very easy to you all, those who are understanding definitely, that how easy it is and why are we even studying memoization, tabulation and all this stuff. But actually in interviews, they will ask you to convert recursion to memoization, memoization to tabulation. These are all three, you can say, approaches to solve the same problem. So although we are solving the same problem, we are solving the problem with three different ways, correct? So let us quickly see the tabulation code of this problem. Now to write tabulation code, I'll simply use what? This DP array which we are using here. Of course, this DP array. So I'll write public uh, integer tabulation, and here I'll pass integer array grid and integer 2D array DP, right? And for tabulation, where do we start the loop and how many loops will be there? How many dimensions is this array having? This DP array, 2 dimensions, so 2 loops will be there, 2 nested loops. This is the first question we are doing where it is not a linear DP, it is 2D DP, right? So 2 parameters in recursion call, 2 like dimensions in the DP array in the memoization, and of course, if 2 dimensions in the DP array, I'll be having 2 nested loops itself. And you can see I want to reach n minus 1 comma n minus 1, right? So both the I and j will be starting from n minus 1 comma n minus 1 all the way to 0, because always in the tabulation the first step is start the loops from the base cases. So for integer I is equal to grid dot length minus 1. So let's say n is equal to grid dot length, and let's say len gth. I think grid is of n cross n, m cross n, okay, len gth, and let us say m is equal to grid of 0 dot length. N is the number of rows and m is the number of columns. N minus 1, I greater than equal to 0, I minus minus. For integer j is equal to m minus 1, j greater than equal to 0, j minus minus, right? So these are the two things I've initialized it with, and now I'm ready to quickly see how we are going to implement the tabulation code for this. Let us quickly implement the tabulation code. So these 2D arrays I'm having, and what do we do? How do we write? What is the tabulation tricks? After writing both loops, I'll simply take whatever memoization I was using. I'll simply copy paste this code here. After copy pasting this code, let me fix the indentation. So yes, after copy pasting the code, all right, this is the code of memoization I've pasted in these two loops. This condition I'll actually remove, right? Because this is the base case condition. This is out of bounds condition, right? Let me just comment this condition right now. The first step is wherever return is written, convert that into continue statement and save the data. Here return is written. I'll do what? DP of I comma j is equal to, I'll save the data and I'll continue. Correct. I'll continue. Correct. And this return statement is also there. I'll save the data and continue. If I simply remove this return statement, I'm actually saving the data in DP of I comma j as well, and I'm continuing as well. So all the return statements are replaced by continue. The out of bound condition, however, we have to handle it right now. Okay, I've not actually continued from here because this is out of bound condition. I have to handle it separately. ध्यान से देखना. So we have handled all the return statements. Now next step is remove this memoization call. This memoization recalling is removed. Wherever the third step is wherever you're calling memoization, just replace it with trying to access DP of I comma j plus 1. We will try to access DP here, right? DP of I plus 1 comma j, right? So correct. Now this is the case we have successfully done. Now we have replaced this with I comma 1 j plus, but one condition is still remaining, that this is not handled, right? All the steps are done. Only this thing is remaining, that we have not successfully handled the out of bounds. Where can we go out of bounds? Can I say on this line of code, j can go out of bounds? Definitely. Here j is going out of bounds. So here what will I write? I'll simply use ternary operators. So j plus 1. If j plus 1 is in the bounds, if j plus 1 is less than m, I will return this. Else, what will I return? I will return this, right? This is the condition. This is the return statement. Like this is the what is what value I want to keep when we are going out of bounds, right? Okay. Because of course, if right is out of bounds, it will become maximum and it will lose from down, right? Because here we are taking minimum, right? So in this line of code, I can go out of bounds. So if I plus 1 is less than n, this means that it is in the bounds. If it is in the bounds, access the DP array. And if it goes out of bounds, just write integer max value, right? So let us quickly return DP of 0 comma 0 from here. And let us quickly call this function from here, return DP of 0 tabulation grid comma DP I'll pass here, and let's see if this code is working. Yeah, it's getting accepted. Let's try to submit this code. Right, so it has got accepted, right? So of course I'm not doing the iteration of on this 2D DP right now of this tabulation code, right? Don't worry, the tabulation in this particular problem, it is fairly easy. We will be seeing the iteration on how to iterate on tabulation code in the next video itself. The next problem is of 2D DP as well, so we are going to see there that how we iterate on a tabulation, right? So I hope you enjoyed this lecture. Thanks for joining. And yes, still hopefully everybody is sleeping in my home, right? So let us meet in the next video itself, and if you are enjoying the content, please like and subscribe to the channel itself. Spread the word with your friends and ask them to watch DP as well. DP is a very interesting and very important topic, right? So thanks a lot everybody for joining in this video. Until the next video drops, bye.